Hello dear students, welcome to the discussion NCERT line by line questions. Today we discuss chapter number 9th, ray optics and optical instruments. Let's move into the questions. The first one, which of the following statements is wrong for an image formation of a real object? Okay. Option 1, the magnification produced by convex mirror is always less than 1. Okay, we have to select the wrong statement. See, the magnification produced by convex mirror is always less than 1. That is true. The statement is correct. Okay, a convex mirror, a convex mirror gives a broad area by reducing the size of the objects. Okay, so the magnification is always less than 1 in the case of a convex mirror. Okay, so this is correct statement. Second one, a virtual inverted same size image can be obtained using a plane mirror. Okay, using a plane mirror, the image is not inverted. Okay, using a plane mirror, we are observing us in a plane mirror, the image is erect only. Okay, so this statement is the wrong one. And what about C? A virtual erect magnified image can be formed using a concave mirror. By using a concave mirror, we can produce a virtual image. Okay, that will be erect and magnified. Okay, this is correct. This statement is true. This statement is true. And fourth one, a real inverted same-sized image can be formed by using a convex mirror. By using a convex mirror, a real inverted same-sized image, okay, can be formed by using a convex mirror. It's possible. Then this one, see, virtual inverted same-size image, inverted. This is the problem there. Okay, it will be erect. It will be erect only. If the object is erect, then the image also will be erect. So the answer is option 2. Clear? Number 2, advanced sunset and delayed sunset, sunrise and delayed sunset. Actually, this is sunrise. Okay, you can correct it. Advanced sunrise and delayed sunset is due to the atmospheric refraction. Okay, it is one of the application of refraction. Okay, or this phenomenon, this advanced sunrise and delayed sunset is due to the phenomenon of refraction of light taking place due to the presence of atmosphere. Clear? So this is the answer, option B or 2. Number 3, if mu A, mu B and mu C are refractive indices of A, B and C, 3 media, respectively, such that mu A greater than mu B greater than mu C. Okay, we are having 3 media A, B and C with refractive indices mu A, mu B and mu C respectively. Total internal reflection can take place when a ray of light travels from. Total internal reflection, we studied it, TIR. Total internal reflection takes place when the ray travels from denser medium to rarer medium. Okay, when the ray passes from denser to, okay, denser to rarer medium. Okay, in that case, total internal reflection taking place. Denser means higher refractive index. Higher refractive index to lower refractive index. Clear? Now, the first one, C to A. C to A. Is that possible? The refractive index of C is less than that of A. Okay, mu A is greatest. Mu A is greatest. So from C to A, TIR is not taking place. Clear? Then C to B. C to B. This is also not possible because refractive index of C is less than that of B. Okay, then B to A. It is also not possible because the refractive index of B is less than that of A. So this is not possible. Then B to C. This is okay. Higher refractive index to lower refractive index, TIR may take place. Good. Number 4. Which of the following concept is used in optical fiber? Okay, in optical fiber, the optical signal is passing due to the multiple total internal reflection. Multiple total internal reflection. Okay, the ray is passing due to, suppose this ray is entered, okay, undergoing TIR, then again TIR, then again TIR in this way. Clear? So total internal reflection, option D is the answer, right? Yes. Number 5. In the position of minimum deviation, when a ray of yellow light passes through the prism, then it's, see, in the case of a prism is to deviate a monochromatic light. Okay. If it is a polychromatic light, dispersion happens. And we can observe VIBGYOR. We studied it. And if it is a monochromatic light, for example, yellow light, what happens? The prism deviates the ray. Deviates. Okay. And in the case of minimum deviation situation. Minimum deviation situation. What is the case of minimum deviation situations? That the ray through the prism passes parallel to the base. The ray passing through the prism will be parallel to the base, BC. Okay, the prism, ABC. So this is the incidenting ray, this is the ray passing through the prism, and this is the emerging ray. Clear? In this situation, we studied the angle of incidence and angle of emergence are equal. We studied it in this situation. Okay, when we have a normal here, the angle between the normal and incident ray, that is the angle of incidence. And when we have a normal here, the angle between the normal and the emergent ray, that is the angle of emergence. Clear? In this situation, this is the case of having minimum deviation. In this situation, angle of incidence is equal to angle of emergence. Angle of incidence is equal to angle of emergence. Option 4th. Okay? Yes. Then number 6, the focal length of a lens depends upon. The focal length of a lens depends upon nature of the material of the lens. Okay, it depends on the refractive index, focal length. Clear? Then see, we studied the lens maker's formula. Lens maker's formula, the well-known formula, 1 by f is equal to n2 divided by n1 minus 1 into 1 by R1 minus 1 by R2. Okay, this is the lens maker's formula. Then the focal length depends on the refractive index of the material and also depends on the refractive index of the surrounding medium. Clear? Nature of the material of lens. Then color of the light. As per the color changes, then the refractive index changes. Okay, for different color, the refractive index is changing and the focal length is changing. So color of light is also a factor. Then medium in which lens is placed. Medium in which lens is placed. This N1 is the refractive index of the surrounding medium. Okay, so the answer is all of these 3 factors. Clear? Okay. Now, number 7th, a screen is placed at a distance of 40 centimeter away from an illuminated object. A converging lens is placed between the source and screen, and a converging lens is placed between the source and the screen. Okay. There is an object. There is an object is there represented by O, and a screen is placed in front of it. Clear? A screen is placed here. A screen is placed, suppose here, let this be the screen. Okay. Now, a converging lens is placed. What is a converging lens? Means a convex lens. Okay. Placed between the source, object, otherwise source. Okay. This is the source. Okay. Between the source and the screen, a convex lens is placed. And it is attempted to form the image of the source on the screen. We are adjusting the position of the lens and we are trying to get the image of this object in the screen. Okay. If no lens position could be found, If no lens position could be found means no image is formed. Okay, a position of lens. Okay, in a particular position of lens in which image is formed. Such a situation is not happening means no image is formed. Clear? Then the focal length of the lens must be what are the condition given in the option. Okay. See, clearly this is the UV method to find out the focal length of a convex lens. UV method. Clear? From the UV method, what we studied from the UV method. Suppose here we have the lens here. Okay. Let the distance of the object from the lens be, let this be x, suppose x, and the distance from the lens to the screen, let it be y. Let it be y. Okay, and the distance between the object and the screen, let it be d, suppose. Okay, distance between the object and the screen be d. Okay, this is the UV method. What we are doing, we are shifting the position of the lens. Okay, accordingly we are checking whether the image is formed in the screen or not. Clear? We have the lens formula as, what is the lens formula? Lens formula studied as 1 by V minus 1 by U is equal to 1 by F. 1 by V minus 1 by U is equal to 1 by F. From this, 1 by V is equal to 1 by F plus 1 by U. Clear? This is equal to U plus F. U plus F divided by U into F. Clear? Then V is equal to the reciprocal. Clear? V, the image distance is equal to U into F divided by U plus F. Okay, we are having one equation. Clear? Yes. Now, another one is, see, here, what about this distance? See, in the question it is given that a screen is placed at a distance of 40 centimeter away from the object. So this distance, capital letter, in the question it is given 40 centimeter. It's clear that D is equal to x plus y. It's very clear. X plus y. D is equal to x plus y. Okay. D is equal to x plus y. D is equal to x plus y. Okay. From this equation, see, we have, what is the value of u? The value of u, that is the distance to the object, is equal to minus x. Clear? According to the sign convention. According to the sign convention, from the lens, we are measuring to the left. Then the sign will be negative. Okay, so u is equal to, I can write u is equal to minus x. Clear? And v is equal to positive y. Positive y. U is equal to minus x. We have u is equal to minus x and v is equal to positive y. Clear? Yes. Okay. Then we can substitute here. V is equal to, what is V is equal to y and U is equal to minus x. It's very clear. From this equation 1, we are placing to equation 1. V is equal to y is equal to U is equal to minus x into F divided by U. See, we need the value of D here, the value of D. So in this equation, let it be equation number 2 and we are putting into it the value of x and the value of y. We can put the value of y. See. From this one, equation 1, we have y is equal to minus x into f divided by minus x plus f. Clear? Yes. Okay, otherwise we can do like this. See, like this. Then equation number 2, put into equation number 2. Equation number 2, what we do? Equation number 2, what we have? D is equal to d is equal to x plus y, x plus y, x plus y. Instead of y, we have v. Instead of y, we have v. Okay, then x plus, instead of y, we have the v. V is equal to what? uf divided by u plus f. U plus f. Clear. And this is equal to x plus, what is u is equal to minus x. Minus x into f divided by minus x plus f. Clear. This is d. Okay. Yes. Now we can do d is equal to x into this one. X into minus x plus f plus minus xf minus xf all divided by minus x plus f. Okay. Minus x plus f. Clear. Now, which are connected in this formula? X, y and d are connected in this formula. Okay. Then this d is equal to minus x square. Okay. Minus xf. Okay. See, this one is plus xf. Okay. Minus x square plus xf minus xf. Clear. Divided by minus x plus f. Okay. This positive xf and negative xf cancelled. Clear. This d is equal to minus x square divided by minus x plus f. Okay. Then cross multiply. D into minus x plus f is equal to minus x square. Clear. Minus x square to this side. We get x square minus xd plus df is equal to 0. We are getting a quadratic equation. This is a quadratic equation. Clear. And the solution of this quadratic equation will be 2 when the determinant is greater than, when the determinant is greater than 0. When the determinant value is greater than 0, we will get 2 solutions. Okay. And when the determinant is 0, we will get 1 solution. And when the determinant is less than 0, there is no x. There is no solution for that. And as per the question here, no position is found means the determinant is less than 0. Okay. So we can find out the determinant of this expression. What is the determinant of this expression is, see what is our equation is, my x square minus xd plus df is equal to 0. Clear. X square minus xd plus df is equal to 0. X square minus xd plus df is equal to 0. Clear. Now, this is the quadratic equation we obtained. X square minus xd plus df is equal to 0. Clear. If its determinant value is greater than 1, we will have 2 solutions. Means we will have 2 values for x. 2 values for x means we will get 2 positions such that the image is formed in the screen. Okay. And if the determinant value is equal to 0, we will have 1 position. And if it is less than 0, which one? If the determinant is less than 0, then no position is found. And as per the question here, no position is found means the determinant is less than 0. And what is the determinant of this quadratic equations? That b square minus 4ac. b square minus 4ac. Here b square is d square. Then minus 4 into a value is 1. C value is df. Okay. This determinant should be less than 0. That's the point. Okay. No image is formed. Okay. Which means d into d minus 4f is less than 0. Isn't it? D is taken outside. Which means d minus 4f is less than 0. Clear. Which means 4f is, this one to that side, 4f is greater than d. 4f is greater than d, which means focal length is greater than d by 4. Focal length is greater than d by 4. And d is given in the question 40 centimeter. In the question, d is given 40 centimeter. Okay, 40 by 4 is 10. Look into the answer, should be greater than 10 centimeter. The answer of the question is that one. Clear? Greater than 40 by 4, that is greater than 10 centimeter. The focal length should be greater than 10 centimeter. Means we are placing a lens between the object and screen whose focal length is greater than 10 centimeter. Then no image is formed on the screen. Simply. You understood? So it's all about the determinant. Keep it in mind. Okay, so the answer is option A. Clear? Yes. Moving to the question number 8. In a compound microscope, the intermediate images. We have a compound microscope. In a compound microscope, there is the object. Okay. And a lens is placed, which is the objective lens. Okay. Objective lens. And there is an eyepiece. This is the situation. Clear? Yes. Okay. Suppose this is the principal axis. Okay. Suppose we are having an object, this one, and we draw the ray diagram. This ray, after refraction, it passes through the focus. Okay. And the other one, suppose we take the ray passing through the pole. Okay. Yes. Then these two rays are diverged into the eye of the observer. These two rays are diverged into the eye of the observer. Okay. This is the eye of the observer. Okay. Then these rays are appeared to be coming from a point. And there is the final image obtained. Clear? And these two rays, after passing through the objective lens, converging here. See? Converging here. And this is a real inverted enlarged image. Real inverted enlarged image, and this is the intermediate image. See? In a compound microscope, the intermediate image is, which is inverted, which is real, okay, which is enlarged. Okay, real, inverted and magnified is our option C. Real, inverted and magnified is option C. That's the answer of the question. It's very easy. Yes. The next one, number 9th. Mark the correct option among following statements. Which are the statements? First one. If far point come closer to eye, the defect is farsightedness. See, we have to mark the correct option. Okay. First one. If far point come closer to eye, the defect is far point. Okay. What is meant by far point? Far point is the point up to which or beyond that point the person cannot view the objects. For example, suppose my far point is 10 meter, which means the objects beyond 10 meter from my eye, I cannot see them clearly. That's the far point. You understood? And what about this statement? If far point come closer, if far point is coming closer, means I cannot see the farther objects. My far point is just 5 meters, suppose, which means there is a vehicle at 50 meter distance from my eye. I cannot clear that vehicle. I cannot see that vehicle clearly. Okay. Which means I can only view nearby objects. I can only view nearby objects. Clear? So here the defect is farsightedness. What is the meaning of farsightedness? Farsightedness means the person can only view further objects. That is the meaning. Farsightedness means he can only view distant objects. That is the farsightedness. And what about this one? Far point is coming closer means further objects or distant objects cannot be viewed. That is this one. And it is farsightedness means it is incorrect. This is incorrect. Okay. And what about B? If near point goes ahead. Near point goes ahead. What is the meaning? I cannot view the nearby objects. That's it. My near point, usually for a person, the near point is, see, 25 centimeter is the least distance of distinct vision. We can clearly view an object at a least distance of 25 centimeter. Okay. Suppose for a person, when we place the book here at a 25 centimeter, our eye is feeling strain means our near point is moved away. Our near point is moved away. Clear? What is the meaning is, we cannot view nearby objects. That's the meaning. We cannot view nearby objects means we can only view distant objects. We can only view distant objects means that is farsightedness. If the near point is moved away, that is farsightedness. Clear? And if the far point is moving closer, that is nearsightedness. Okay. So if near point goes ahead, the defect is called myopia. No, it is incorrect. What's the defect called? Myopia means we can only view nearby objects. Nearby objects. So this is incorrect. Clear? If defective far point is 1 meter away from eye, divergent lens should be used. Why divergent lens used? Divergent lens used because, see, our eye lens is converging the rays. Our eye lens is converging the rays. Okay, in front of the retina. Okay, that's the point. That's why in front of the retina. So we have to place the object further away. Clear? Due to the more divergence, more convergence. Okay. Suppose if I am viewing this, the rays coming and passing through the lens and the rays are converged in front of the retina. That's why I feel strain. So I will move back this marker to further away. Means I can only view further objects. Okay. So in this condition, in order to view this one clearly, I use a diverging lens. Means a lens having negative power. Diverging lens. So if defective far point is 1 meter away from eye, divergent lens should be used. Yes. Okay. Suppose I need to read a newspaper and I am placing this 1 meter away. 1 meter away. Clear? Why? Because what's the problem? I have to use a diverging lens. Clear? Is this correct? The last example is incorrect. What I said in the case of newspapers, if I am reading a newspaper, this one is focused beyond my retina. Beyond my retina. That's why I am placing this further away. Okay. Then I have to use a converging lens. That's a convex lens. Clear? Yes. Clear? Yes. If I am reading this one nearby objects, the image formed. See, suppose this is the eye lens. It's very clear, no problem. And suppose this one, the nearby objects. See, these rays are. So this is the retina. The rays are. The rays are converging beyond the retina. Beyond the retina. Okay. In this condition, I have to use a converging lens. Clear? Because nearby objects are not viewed clearly and this is farsightedness. This is farsightedness, so I want to use a converging lens means or a convex lens. Clear? Now, if the far point is 1 meter away from the eye, far point is 1 meter away from the eye means I cannot view objects beyond 1 meter. That is meant by far point. Beyond 1 meter, I cannot see objects. Why? Why it happens? Because why it happens? Suppose here, listen. Suppose an object is far away. Then its rays are converged beyond, in front of the retina. Okay. Then what the person do? The person will shift this to nearer to his eye. Okay. This object is shifted nearer to his eye. Then this point will be exactly at the retina. Then he can view that. Okay. So in this situation, what he has to use? He has to use a diverging lens. A diverging lens means these rays are diverged. These rays are diverged and exactly on the retina. Clear? Means if far point is 1 meter away only, means after 1 meter the person cannot view. Okay. Then in that situation, he will use a diverging lens, and this is the correct option, and that's the answer of the question. And what about the fourth one is, if near point is 1 meter away from eye, divergent lens should be used. If near point means, if the object is more closer, then what happened? This divergent lens should be used is incorrect. What he has to use? He has to use a converging lens. Clear? So the correct option is option C only. I think you understood it properly. Moving to the next one, 10th. P. Look into the figure. P is a small angled prism of angle 3 degree made from material of refractive index 1.2. Okay. A ray of light is incident on it as shown in the figure. The angle of deviation for the rays refracted from the prism is the angle of deviation. Clear? Okay. See, the diagram is of a small angled prism whose angle is 3 degree. 3 degree here. Okay, very small angle. Now, a ray is incidenting on this face normally. A ray is incidenting on the face normally. Let this be that ray. Okay. This is normal incidence. Clear? Then the ray will not suffer any deviation and it will move as it is. Normal incidence. It will move as it is. Okay. Yes. And now here this ray is moving from denser to rarer. The ray is now moved from denser to rarer. This is the normal drawn. Okay. Denser to rarer means will bend away from the normal. Will bend away from the normal. The ray will bend away from the normal. Deviation. Okay. Yes. So the deviation, angle of deviation is the angle between the incident direction and the refracted direction. This is the refracted ray. So the angle of deviation is the angle between, this is the incident direction. Okay. Okay, this was the direction of the ray earlier. That direction and the new direction is creating an angle here. And this is the angle of deviation delta. Suppose. Angle of deviation, and it is asked here in the question. This is actually the exact figure. You understood? Incident ray, refracted ray, and there is an angle. And how much is this angle of deviation is asked? Clear? Now, the refractive index of the material is given 1.2. This prism having refractive index of 1.2, and we take this is surrounding medium as area and its refractive index is taken as 1. Clear? Okay. Now, here the angle is 90 degree. Okay. Then what about this angle? This angle. The total angle is 180. Clear. 3 plus 90 plus this should be 87. Clear. Okay. This angle should be 90 minus theta. 90 minus 3. So this is 87 degree. This one. 87 degree. Okay. And what is this total angle? See. Listen here. This total angle. This total angle is 90 degree because this is normal. This is normal drawn. So this is totally 90 degree. Okay. Out of this angle is 87. Then what will be this remaining angle? This remaining angle will be 3 degree here. I think it's clear to you. Okay, this surface and this line are perpendicular to each other. So this is totally 90. Out of this 87, the remaining is 3 degree here. Okay, yes, 3 degree. Now, see, this angle is 3 degree means this angle is also 3 degree. Is that okay? This direction and this direction. These two directions are setting an angle here 3 degree. Then here also it will be 3 degree. 3 degree. Clear? Yes. Now what about this total angle? See, this total angle is the angle of refraction. Okay. This 3 degree plus delta is the angle of refraction. What is the angle of refraction? Is the angle between the normal and refracted ray. Okay, so this total angle is angle of refraction. Angle of refraction is here 3 degree plus delta. 3 degree plus deviation angle. Okay, so we need to get a deviation angle, that is r minus 3 degree. Deviation angle is r minus 3 degree. Okay, we can easily calculate r from Snell's law. Snell's law of refraction. Snell's law of refraction. What? Refractive index of this medium into angle of incidence 3, that is 1.2 into sine 3 degree is equal to refractive index of this medium into angle of refraction. Refractive index of that medium is 1 into angle of refraction is sine r. Isn't it? Yes. And since this 3 degree is very less, we can take it as 3. Sine theta is approximately theta, if theta is very small. Yes. So this is 1.2 into 3 degree is equal to sine r. Clear? That is 3.6 degree is equal to sine r. Okay. See, this is not degrees, this is just 3. Okay, if I am placing so, you can take it as 3.6 and then here this r value you take as 3.6 degree, which means approximately. Actually, we don't say sine r is equal to 3.6 degree. Sine r is just a number. Sine r is just a number. Clear? Yes. So these two steps are incorrect actually while we write. So what we can write is, see, this one, this should be first of all converted into radian. Okay. So I'm just taking this as in degree itself, sine 3 is 3, then 3.6, that is sine r, which means r is approximately, r is very nearly 3.6 degree. R is very nearly 3.6 degree. Clear? Yes. Okay. Because this is a very small angle. This is a very small value. This is a very small value. Sin r is equal to a very small value. Then that will be equal to r itself. R itself. So r is 3.6 degree. We can write so. No problem. And what about this deviation angle from this? Deviation is r minus 3 degree. Deviation is r minus 3 degree. 3.6 minus 3, which is equal to 0.6 degree. It's very clear. 0.6 degree. The answer is option D. I think you understood properly. Okay. Moving to the next one, number 11th. When white light enters to a prism, it gets split into its constituent colors. This is due to the dispersion of light, or this phenomenon is called a dispersion of light. A compound microscope consists of an objective lens of focal length 1 centimeter. Focal length of the objective lens is 1 meter. Is that meter? No, it is in centimeter. 1 centimeter. An eyepiece with focal length of 2 centimeter. Focal length of eye lens is equal to 2 centimeter. And tube length is 20 centimeter. The length of the tube is equal to 20 centimeter. What is its magnification? Magnification of a compound microscope. Magnification of a compound microscope is magnification of objective lens into magnification of eye lens. Magnification of objective into magnification of eye lens. Clear? Yes. Okay. This is equal to L by FO into D by FE. You studied that formula. L by FO into D by FE, the magnification of a compound microscope. Tube length L is here 20 centimeter. And the focal length of objective is 1. Okay. Then D, the least distance of distinct vision is 25 centimeter. You know D, the least distance of distinct vision 25 centimeter in the case of normal eye. 25 divided by FE is 2 centimeter. Okay, centimeter will be cancelled. 20 by 2, 10. 10 into 25 is 250. Is the magnification of this particular compound microscope. 250 is option D. Option 4. Clear? Very direct. The next one, 13th. With regards to a telescope, which statement is incorrect? Telescope. Telescope is used to provide angular magnification of distant objects. This is true. Okay. We are observing distant objects which are actually big. Okay. So the image is not bigger than the size of the object. Not bigger. Okay. Then what the telescope is doing? It is providing the angular magnification. Okay, when we observe that distant object, the star, without the telescope, this angle subtended at the eye is very, very small. That's why we observe it as a very diminished one. And the telescope is increasing this angular magnification, and that's why we can clearly view that one. That's the case. Telescope has objective lens of large power. Telescope has objective lens of large power. A greater focal length objective lens the telescope will have. Generally, the objective lens has greater focal length. Final image of refracting telescope is erect. Final image of the refracting telescope is... What about the final image? Final image of the refracting telescope. It will be inverted. You know, the final image is inverted, right? Final image of the refracting telescope. It is inverted. The final image formed. It is inverted. So this is the incorrect statement. With larger diameter of objective, fainter objects can be observed. That's the purpose of larger diameter. It can gather more light. So that's the purpose of objective lens itself. Then this is the answer. The incorrect one is option 3. Okay. 14th. Match the elements of list 1 with list 2, list 1A. Simple microscope. Simple microscope. Simple microscope is producing just a convex lens. Okay. Image is magnified, inverted and virtual. Is that true? No, it is incorrect. Okay. Then this is the answer of that one, right? Just check. Image is virtual and it is erect and enlarged. Okay. In the case of a simple microscope, image is virtual, erect and enlarged. Okay. Then A is H. A is linked with H. First one, second one, third one, and these three are. Then what about it? Compound microscope? Compound microscope. See, image is magnified. Image is magnified, that is true. Inverted, that is true. And it is virtual, that is true. In the case of compound microscope, image is magnified, it is inverted, and it is virtual. It is true. So, B is of E. B is of E means this one eliminated, this one already eliminated. Now, we are having 2 and 3. Okay, see, astronomical telescope. Astronomical telescope means we are observing distant objects like stars. What it is? If image is virtual, erect and high resolution. Image is virtual and erect. It is incorrect. Virtual means here inverted. Astronomical telescope. Astronomical telescope is this one, G. Then what about this? C goes to G. So this is our answer actually. And check the D, terrestrial telescope. Terrestrial telescope, we are observing the nearby. In that case, this one image is virtual, erect and high resolution. So our answer is option B only. Okay. The next 15th. A simple magnifier has converging lens of focal length 2.5 centimeter. A simple magnifier means a single convex lens with a focal length 2.5 centimeter. What is its linear magnification for the image formed at the near point? The image formed at the near point, the magnification M is equal to 1 plus D by F. Okay. And if the image is formed at infinity, then that is the relaxed vision. In that case, magnification is a little bit reduced and it will be D by F. When we adjust the situation such that the image is in the relaxed view, then this is D by F. And if the final image is adjusted in the least distance of distinct vision, then the magnification is a little bit greater, 1 plus D by F. 1 plus 25 divided by 2.5. This is equal to 11. Okay. Magnification is 11, option 3. Good. Number 16. A prism has angle of 60 degree. A prism has angle of 60 degree and its absolute refractive index is 1.76. The angle of prism A is equal to 60 degree and the refractive index of the material of the prism N is equal to 1.76. The prism is dipped in a transparent liquid of refractive index X. The prism is placed in a transparent liquid whose refractive index of the liquid is X. If the angle of minimum deviation is found to be 46 degree, angle of minimum deviation lettered by capital D 46 degree in the liquid, then what is X value? We have the relation connecting refractive index. The refractive index of the prism when the prism is placed in air or vacuum is N is equal to sine of A plus D by 2, sine of A plus D divided by 2 divided by sine of A by 2. Sine of A by 2. Okay. Sine of A by 2. Sine of A plus D by 2 divided by sine of A by 2. This is when the prism is in air. Okay. When the surrounding medium is air. Otherwise, this becomes N2 by N1. N2 by N1 is equal to sine of A plus D by 2 divided by sine of A by 2. Okay. Yes. Here, in this question, this is the situation. Refractive index of prism is given and there are the surrounding medium, that is the liquid. refractive index x is given. So here 1.76 by x is equal to sine of A is 60, D is 46. 60 plus 46, 106. 106 by 2 is 53. Sine 53 divided by sine A by 2, sine of 30 degree. Okay. What is sine 53? We study this triangle 3, 4, 5 right angle triangle. 3, 4, 5 right angle triangle. Then the angle opposite to 4. The angle opposite to 4 is 53 degree. Okay. And the angle opposite to 3 is 37. The angle opposite to 5 is 90. Clear? 90 degree, 37 degree, 53 degree. Clear? And what about sine 53 from this triangle? Sine 53 degree is equal to 4 by 5. 4 by 5. Okay. 1.76 by x is equal to 4 by 5. And here sine 30 is 1 by 2. 2 to the numerator. 2 into 4, 8. 8 by 5. Clear? 1.76. What about this one is 8 by 5. Okay. Then x is equal to 5 into 1.76 by 8. X value is 5 into 1.76 divided by 8. Isn't it? Yes. X is equal to 5 into 1.76 divided by 8. Okay. Let's check. 5 into 1.76. 5. Then 1.76 into 5. 33. 7 into 5, 35. Plus 3, 38. 1 into 5. Then 8. 8.8. 8.8 divided by 8, that is 1.1. Okay. 1.1 is the answer, option A. Clear? Good. The next one, question number 17th. Find the position of the image formed by lens combination with convex lens of focal length 10 cm and concave lens of focal length 12 cm. Convex lens of focal length 10 cm, concave of focal length 12 cm. Okay. The object is kept at 30 cm from the convex lens as shown. Okay. Here are two types of image formation. One is by the convex lens and the second one by concave lens. First of all, image formation by convex lens. Image formation by convex lens. Okay. The final image formed by the convex lens is at a distance from the convex lens V is equal to UF divided by U minus F, U plus F. Okay. V is equal to UF divided by U plus F. Clear? This is equal to U is equal to minus 30 centimeter. F is positive in the case of convex 10 divided by minus 30 plus 10 is equal to minus 300 divided by minus 20. Minus cancel. This is 15 centimeter. Okay. The image formed by the convex lens is at 15 centimeter away from the convex lens. Okay. So it will be beyond this concave lens because this distance is 6 centimeter. Then further 9 centimeter more. Then only this is 15 centimeter. Okay. Then we will have the image formed by convex lens somewhere here. 9 more centimeter away. Let it be here. This image is I am marking as I dash. I dash is the image formed by convex lens. At how much distance away? 9 centimeter away. Okay. Yes. Now, this I dash behaves as the virtual object for the concave lens. For the concave lens, I dash behaves as the virtual object. Virtual object. Okay. So, if we draw the rays coming from the object, these are like this, moving to this point, they are heading to this point. If there is no concave lens placed here, these two rays are heading to I dash. You understood? But actually there is the concave lens. This concave lens will diverge these two rays. You understood? I can draw here. Here is the convex. Here is the object placed. I am drawing two rays. This one and this one. Okay. This is the principal axis. Okay. These rays are heading to this point. And here is our I dash. Actually, at what distance? 15 centimeter. Clear? Yes. Now we are placed this concave lens here. We have placed concave lens there. Okay. Then these rays are not converging here, because this concave lens will diverge these two rays. Diverge. Okay. Yes. Like. Okay. Now listen. These rays appear to be moving to this point. Actually. Now this behaves as the virtual object for the concave lens. Okay. Now what this concave lens is doing, that it diverges these two rays. Clear? See, the center, the center of curvature, I can mark somewhere here from the center of curvature of this face, see, and if you draw a normal, then what this ray moving from higher refractive index to lower refractive index will bend away from the normal. And this also will bend away from the normal. Diverging. And these rays will move to this one. Move to this point. And here the final image is formed. This is the final image formed. This is actually the ray diagram. Okay, this I dash behaves as the virtual object for the concave lens, and this producing the final image I there. Okay, so the final image is formed to the right of concave lens. This is happening. Clear? So for the concave lens, the image formation by the concave lens, I am writing here, concave lens image formation. The final image position is at a distance v is equal to uf divided by u plus f. Okay. And what is u? U, the distance from the lens to the virtual object is 9 centimeter. 9 centimeter and its sign is positive. Okay. For the virtual object, the sign is positive. Into focal length of concave lens is negative. What is the focal length of this concave lens given? Focal length is 12 centimeter. 12 centimeter, okay. 12 minus 12 divided by u plus f. 9 plus minus 12 is equal to minus 108 divided by minus 3 is equal to 36 centimeter positive. 36 centimeter positive. Here u is taken positive and v is also obtained positive, means the final image is formed at the same side of the object. Object is I dash, not this one. This is the object for convex lens, and the object for concave lens is I dash. So final image formed is at the same side of I dash. At what distance away from the concave lens? 36 centimeter away from concave lens, and you check the options. 30 centimeter to the right of convex from this 36. No. 30 centimeter to the right of concave lens from this 36. That is true. The answer is option B. Understood? Yes. The next one, 18th. A small pin fixed on the tabletop is viewed from above from a distance of 40 centimeter. there is a small pin. It is viewed from above 40 centimeter. Okay. Yes. By what distance would the pin appear to be raised if viewed from the same point through a 12 centimeter thick glass slab? Clear. Here is the table, and there is an object there, a pin or something like. Let this be the object O. Clear. And it is viewed from 40 centimeter I. 40 centimeter. Okay. Now, a glass slab of 12 centimeter is placed here. A glass slab of 12 centimeter. A glass slab of 12 centimeter is placed here. This is of 12 centimeter. Clear? Then this object appear to be raised when viewed from above. This is the case of real depth and apparent depth. We studied it. And what's the formula connecting real depth and apparent depth? Is that real depth and apparent depth. Real and apparent depth. Let it. We have N2 divided by N1 is equal to D real divided by D apparent. That's the formula. And what is N2? N2 is the refractive index of the medium from which the ray is going. N2 and N1. See, when viewed from above, the rays are coming from the object. The rays are coming from the object, from the glass, from the medium glass to air. So N2 is very important to understand N2 and N1. N2, the refractive index of which medium? Okay. It is the refractive index of the medium from which the ray is coming. In this observation, the ray is coming from glass to air. So the refractive index of glass is here. The refractive index of glass is 1.5. So 1.5 divided by that of air is 1. Okay. Then the real depth. What's the real depth? The real depth is, see, these two distances, very, very important. These two distances are to be measured from the surface. From the surface. This is the boundary separating the two media. Okay. So from the surface, how much distance is there to the object? This is the real depth. Understand it. dr. And it is appeared to be raised due to refraction. This is appeared to be raised. Okay, and let this be the image from otherwise O dash. Okay, then from the surface, what is this distance? Is the apparent depth, d apparent. Okay, both dr and da should be measured from the surface. Good. Then from the surface, the real depth is 12. And from the surface, what is the apparent depth is dA. We have to calculate dA. So what is dA is equal to 12 divided by dA is equal to 12 divided by 1.5. 1.5. Okay. 12 divided by 1.5 is 3 by 2. Okay. 2 to numerator. 2 into 12 is 24. Okay. By 3. Okay. That is 8 centimeter. Okay, apparent. This one is obtained to be 8 centimeter. From where? From the surface of the glass slab, this distance is 8 centimeter. Okay, then what will be the distance of O dash from the eye, from the point of observation? From the point of observation, how much is this distance? This distance is totally 40 and this is 12. So this distance is 28 centimeter. Clear? And what about the question is, how much distance it is raised? Would the pin appear to be raised? How much distance it is raised See, this is 8 and this is 12. Then how much it is raised? It is raised by 4 centimeter. 12 and 8. So how much it is raised? It is raised by 4 centimeter. It is raised by 4 centimeter. Option A is the correct answer. I hope you understood clearly. Okay, moving to the next one. Biconvex lenses are to be manufactured from glass of refractive index 1.5 with both faces of same radii of curvature. Okay, the refractive index of the material of the lens is 1.5 and R1 is equal to R2, same magnitude. The radius of curvature required, if focal length is 15 centimeter will be, the focal length of the lens is given 15 centimeter, then what should be the value of this radius of curvature is asked. What is lens maker's formula? The famous lens maker's formula, based on which we are solving this. Okay, 1 by f is equal to n2 by n1 minus 1 into 1 by r1 minus 1 by r2. This is the lens maker's formula. Okay, in the case of a biconvex lens, okay, this one is N2. Refractive index of the lens is N2 and the surrounding medium is N1. Okay, and radius of curvature of this face is R1 and this second face is R2. Clear? Okay, then we can place the values. F is equal to 15 centimeter positive convex lens. N2 is 1.5, isn't it? Surrounding medium is air minus 1 into 1 by, let this value be R, positive R, this value positive R minus 1 divided by, then what about the radius of curvature of the second face will be minus R. Sign convention is very important. Otherwise, this term will be 0. 1 by r minus 1 by r and focal length is 0 is meaningless. Okay, R1 is positive R. So, R2 is negative R because it is measured in the opposite sense. Minus R. Clear? Yes. 1 by r minus minus plus. 1 by r plus 1 by r. That is 2 by r. Okay. 1 by 15 is equal to 1.5 minus 1 is 0.5. That is 1 by 2. Into 2 by r. Okay, 1 by r plus 1 by r, 2 by r. 2 into 0.5, that is 1. 1 by r. 1 by r is 1 by 15, means r is equal to 15 centimeter. R, the radius of curvature needed is equal to 15 centimeter. Obtained. Clear? Yes. The final question is, a light pipe is made of glass fiber of refractive index 1.57. The outer covering of the pipe is made of a material of refractive index 1.3x. A light pipe is made of glass fiber, means this is optical fiber. Optical fiber. Yes. It's an optical fiber. Okay. It has a core, we know, it has a core of higher refractive index. Clear? This material is core of higher refractive index. Clear? And it has an outer layer named cladding. This is of lower refractive index. Okay? This is a longitudinal section of the fiber is drawn here. This is the fiber and its longitudinal section is drawn here. This outer covering is this one, this white layer is the outer covering whose refractive index is less. Understood? Okay. Now a ray is entering into this one. Okay. And what about it? The range of angles of incident rays with the axis of the pipe for which total internal reflection inside the pipe take place is nearly the range of angle of incident rays from the axis of the pipe. Then it's better drawing this one horizontally. Okay. Yes. This is the core material, glass material, and the outer layer is drawn like this. This is of smaller refractive index, then only total internal reflection takes place if the ray traveling from denser to rarer medium. Okay, this is a longitudinal section view. You understood? Yes. And what about the axis of the pipe? The axis of the pipe, let this be the axis of the pipe. Axis of the pipe. Okay. Now, an incident ray. Incident ray is incidenting here. Incident ray. This is the angle of incidence here, I. Understand? From rarer to denser, so it will bend towards the normal, bending toward the normal. Understood? Okay. Now here it suffers total internal reflection. It suffers total internal reflection like this. This is the situation we studied. Clear? Yeah. Then this angle here, see, this angle should be greater than critical angle. This angle here should be greater than critical angle. I may write this is theta. For total internal reflection to take place, theta should be greater than critical angle IC. Okay. Now listen. When theta is increasing, then only TIR takes place. Okay. The minimum value of theta should be IC. The minimum value of theta should be IC. Understood. And what about this angle here? What about this angle here? Let it be R. See, this angle is 90 degree. See. Then what about this R value? Listen carefully. R value is 90 minus theta. Yes. Totally, what about this? Totally 180. Total angle 180 out of this 90. So this R plus theta is 90. So R is 90 minus theta. Good. Okay. Now, total internal reflection takes place when theta is increasing. When theta is increasing means R is decreasing. R is decreasing. Theta is increasing means R is decreasing. I think you understood. Okay. So what is the maximum value of R possible? The maximum value of R possible such that the minimum value of theta applied here. What is the minimum value of theta applied for TIR is IC. Understand? The minimum value of theta. Theta should be greater than IC for TIR. For TIR, total internal reflection, theta should be greater than IC. Okay. So the minimum value of theta is, we can take it as IC. Theta minimum. So I'm taking theta minimum as IC. I'm writing this R max, the maximum value of R here. R max. R max. R max. Why I'm calculating R max? Then only I can calculate this I max. You understand? This I and this R are proportional. That is Snell's law. Sin I proportional to sin R. Okay. I need I max. For that, I need R max. And what is the R max is such that theta is minimum. 90 minus, what is the minimum value of theta is? Critical angle. Critical angle. IC. Critical angle. And what about IC? IC, sin IC, we studied the formula. Sin IC is equal to refractive index of second medium divided by here, not this one. Here, this ray is passing from a denser to rarer. The rarer medium is the cladding here. Denser to rarer. Okay. Then what about sin IC is equal to refractive index sin IC. What is sin IC? Refractive index of this one, that is how much it is? How much it is? 1.36. 1.36 divided by the refractive index of this core. The refractive index of the core is 1.57. 1.57. Okay, 1.36 divided by 1.57, it will be nearly 0.866, etc. Okay. Yes. Accordingly, we find IC value is equal to approximately 60 degree. You can calculate it. Approximately 60 degree IC value. Okay. Then what about this R max value is, I can write here. R max value is equal to approximately 90 minus 60 is equal to 30 degree. 30 degree. Okay. So this maximum possible value of R is 30 degree. For that, what is the maximum possible value of I? Now you look into this one here. Okay. In this surface, I am applying Snell's law that 1 into sine I max. Listen carefully. Snell's law we are writing. 1 into sine I max is equal to 1.57 into sine of R max. R max is 30 degree. Snell's law. 1 into sine I max equal 1.57 into sine 30. Sine 30 is 1 by 2. Clear? This is 1.57 into 1 by 2. This is sine I max. From this, we get I max value. And I max value is nearly 52 degree. You can easily get it. 1.57 divided by 2. And sine inverse of that value is the I max value. Okay, so for the ray to pass through this optical fiber, see this I, the minimum value of I can be 0. Okay, what this angle from the axis, from the axis 0 degree to I max. 0 to I max. And what is I max? This approximate value of I max is 52 degree we get from this calculation. Sine inverse of this value 52 degree will get. So 0 to 52 degree we can range this angle. 0 is this one. 0 is this one. 1, 2, 3, 4, 5, 6, etc. Up to how much angle? Up to 52 degree we can range this incident ray such that total internal reflection taking place and the rays passing through this optical fiber. Understood? So what the answer is 0 degree to 52 degree. Actually, this is nearly 52 degree only. That's the answer. Understood? I hope you understood it clearly. The questions are simple. Okay? You go through all the questions if needed once again. Study well. See you in the next video. Thank you.